Okay, so we have here the different laboratory tests for diagnosis of our gram-negative Enterobacteriaceae. The first one, we have here the serological test for identification of the different antigens. Serological test, since we are detecting for the antigen, all you need to have here would be the bacterial inoculum. So, gagawa ka ng bacterial suspension, and then try to add your corresponding na mga anti-sera. Like for this one, for the identification of your O, somatic antigen, then you'll be needing anti-O, antibody, parang ganun. We have also here anti-K, and we have also here anti-H. So pag nag-positive siya, observe here for the agglutination reaction lang. Okay, so this is very important here for serological typing for different antigens, especially for those na may mga flagella, for those na may mga capsule. And all of them would have here the O somatic antigen because again, they belong to your gram-negative. Lahat ng gram-negative natin, they have a O or somatic antigen because it's part of their endotoxin. Okay, so again, this includes here the three antigens. We have here the O, the somatic antigen, found here in the outer membrane, specifically on the lipopolysaccharide portion, the outer membrane. Then we have also the K or the capsular antigen, and we have also here your H antigen or the flagellar antigen. Okay, for the O antigens, expect them to have a positive result because again, they belong to your gram-negative and part of the component ng kanilang mga ng gram-negative natin ng kanilang outer membrane, they have this endotoxin as part of your somatic antigen. For your K or the capsular antigen, so it eventually found here on certain Enterobacteriaceae like your E. coli. Your Salmonella contains the capsular antigen in the form the VI antigen. Your Klebsiella pneumoniae, of course, may capsule din siya, and Citrobacter would also have the capsule. H for the flagellar antigen for the motility. So lahat ng motil natin, they have their H antigen. Again, except ang hindi lang motil natin ay Klebsiella, Shigella, and even your Yersinia, especially the Yersinia pestis. First one, we have here O or somatic antigen. So basically, that one part of the outer membrane. This is a heat-stable na toxin. Pag sinabing heat-stable, hindi siya na-destroy ng heating process. And that one is lipopolysaccharide. The K or the capsular antigen on the other hand is heat labile. So nasisira siya ng ating heating process. And that one is polysaccharide. In identification of your capsular antigen, medyo nasa loob siya ni ating O or somatic antigen. For the bacteria having the capsular antigen, of course, they really have the somatic antigen. You need to hit this one in order for you to destroy the O or somatic antigen. That's 100 degrees Celsius for 10 minutes to allow exposure of your capsular antigen in order for that to give a positive reaction when you are performing your serological typing or testing. Kasi pag hindi mo siya, try to destroy this one, it might give a negative result because this one try to mask the presence of your capsular antigen. Next, we have here the H antigen or the flagellar antigen. So this is a heat labile then, and specifically that one is made up of the protein component. Okay, so we have here the Kaufman-White classification for the flagellar. This is classification based on the flagella. Okay, I think that one is mga peritrichos, monotrichos, phaetrichos, and we have your atrichos. Ganun. Okay, now we go to the selective media for your Enterobacteriaceae. Okay, so this more of the selective and differential media. Okay, the first one, we have your McConkey agar. So your McConkey agar is basically made up of the biosols, the neutral red, and cruciviolet, which are inhibitory to your gram-positive organisms. And therefore, mag-grow lang ang ating gram-negative, especially your Enterobacteriaceae, because we wanted to isolate that organisms and we don't want other organism to grow. So that's why you are having that mga dyes na nilalagay dito sa ating McConkey agar. Then ang carbohydrate natin, we have here the lactose. Okay, so that will help us to differentiate your Enterobacteriaceae as to their lactose fermentation. Then we have the neutral red as your indicator to differentiate if this is lacto fermenter or non-lacto fermenter based on their color reaction. So itong rule natin, non-lacto fermenter includes your Salmonella, Shigella, and Proteus. All the rest, consider them as your lacto fermenter. Okay, the lacto fermenter for this one appears to be, okay, produces here a pink na colony, whereas your non-lacto fermenter, we have here the colorless na colony. So kung ito, they are non-lacto fermenters, so expect them to be colorless. In the case of your E. coli, this one is lacto fermenter, so E. coli would appear to be pink dito. Okay, based on that, okay, na ano natin na idea natin. On the next one, we have your EMB, eosine methylene blue. So the eosine methylene blue is another dye which try to inhibit your gram-positive organisms, allowing only to grow your gram-negative. That's why ginagamit ito for your isolation of your gram-negative na bacilli because of that inhibitory activity of the EMB. And then again, we have also here the lactose as a carbohydrate content of your EMB. And with this colony, with this culture media, it will help us then to differentiate if your organism is lactose fermenter or non-lactose fermenter. Lactose fermenter, again, appears to be dark purple na color. In the case of your E. coli, that would have your greenish metallic sheen. So that would really the distinct characteristic ng E. coli natin in your EMB. Then your non-lactose fermenter would still appears to be colorless. So ito ay mga non-lactose fermenters, so therefore this still produces your colorless na colony. And all the other na mga lactose fermenter natin, they would have your purple na colony. And then a very characteristic na metallic sheen, greenish metallic sheen in the case of your Escherichia coli. Next one, your Hectoinenteric Agar. So it contains your biosos. Again, this is inhibitory to your gram-positive organisms. In terms of the carbohydrate, it contains lactose and the sucrose. And therefore, expect your Hectoinenteric Agar to differentiate your lactose and sucre fermenter and your lactose and your non-fermenter. Okay, then we have here your indicators, your bromthymol blue. Another one contains your ferric ammonium citrate that would allow you to identify if your organism here would be, okay, H2S producer. Again, pag may H2S, napoproduce siya ng H2S, expect to have here the blackening of the colony, and sodium thiosulfate would have here a sulfur na source. Again, ang ma-identify natin sa Hectoinenteric Agar would be the lactose sucre fermentation, and even if your organism here is capable of your H2S production. Okay, so we have here the result of your Hectoinenteric Agar. So Hectoinenteric Agar will identify organism here as either lactose and sucrose fermenter to be having that orange, salmon orange na colony, whereas the lactose and sucrose non-fermenter would have here the, tama ba? Non-fermenter would have your bluish green na colony. And then because of the ferric ammonium citrate, it also allows you to detect the presence of those organisms here having capable of the formation or the H2S formation or producing a black na colony. Example, E. coli, we consider E. coli here as a lactose fermenter, so therefore it will appear to be salmon orange. Salmonella is non-lactose, so it appears to be bluish green. But remember, Salmonella would have an H2S, and therefore bluish green siya, meron siyang black center or blackening of the colony. Shigella is also non-lactose fermenter, and therefore this one would be characterized here by bluish green na colony, wala siyang black center because hindi siya H2S producer. The next one, we have your cytoslysin, the oxidation agar. So this one contains your sodium deoxycholate that inhibit the growth of your gram-positive organisms. So this one would have the xylose of the carbohydrate that will help us then to identify our bacteria here if that one try to ferment the xylose or not. Then we have also your phenol red as an indicator, ferric ammonium citrate, and the sodium thiosulfate that would help us then to identify if your organism try to produce here H2S. So it will be detected in your cytoslysin sugar or cytoslysin the oxidation na agar. Okay, for the xylose fermenter, this one would have here na yellow na colony. And for the xylose fermenter, it would have here na red na colony. E. coli. So, E. coli is xylose fermenter. Wait lang. Ang xylose fermenter natin, lahat din ng mga lactose fermenter natin are xylose fermenter plus your proteus. But your proteus in the lactose fermentation, we consider that ones were non-lactose fermenter. But in the xylose, it will have here the xylose fermenter siya. Again, E. coli being a xylose fermenter would have here na yellow na colony. Salmonella would have, this one is a xylose non-fermenter. So it would have your red na colony plus my black because again, may H2S ito. Shigella would have your red na colony because xylose non-fermenter siya at wala siyang black na colony. Proteus would have your yellow na colony plus black because our proteus would have here the H2S. Meron siyang H2S. Okay, the next one, we have the SSA or Salmonella Shigella Agar. This one contains here the biosols and brilliant green that try to inhibit the growth of your gram-positive na bacteria. And it also contains the lactose as a carbohydrate source, so that would help you then to differentiate your organism here as the lactose fermenter or hindi. Plus, meron din siyang its indicators in the form of your neutral red. Okay, then we have here sodium thiosulfate for the H2S production that will help you identify by blackening of the colony. And another one, you still have your sodium thiosulfate as a sulfur na source. Okay, the lactose fermenter here in your SSA would still be pink to color, pink to red, mga ganon. And then we have here the non-lactose fermenter in the SSA would appear to be colorless. Okay, Klebsiella pneumoniae, we consider this one as the fermenter, lactose fermenter, so it would have here na pink na colony. Since wala siyang H2S, so walang blackening of the colony. E. coli would appear to be na pink na colony and wala din siyang H2S, so walang blackening of the colony. Salmonella would have here colorless because of this one, pero it would have appears to be black siya because meron siyang H2S. Proteus, on the other hand, is also non-lactose fermenter, so it almost dapat colorless. And of course, here black, may black siya, most likely black makikita natin instead of the colorless. Pseudomonas, again, Pseudomonas will not grow in this one because this culture media is only for Enterobacteriaceae. And the Pseudomonas na group do not belong to your Enterobacteriaceae. Then we have your CIN, agars. This is very selective for our Yersinia. Okay, it will have your pink na colony, your Strepsolodine, ergasan, novobiosin agar. Enrichment broth here will have inhibit the growth of your gram-positive na organism. Example for that, we have selenite F. Selenite F would allow the growth of your gram-negative organism, but it will allow specifically the growth of your non-lactose fermenter, but not your lactose fermenter. Okay, then we have also here the test for the carbohydrate utilization. So some of your bacteria, Enterobacteriaceae, try to utilize the carbohydrates or sugar as their carbon source. The first one, we have here the oxidation fermentation tube. So basically, this one is the OF that will identify as if your bacteria able to oxidize your glucose or even ferments your glucose. The culture media used for that is your Ulifeson OF basal medium. It's culture media na wherein it is being incorporated with your 1% na glucose. The sugar is glucose on that. Plus may 2% siya, ay 0.2% na peptone. Original color nito is green. So there are two tubes for that. One is left open. Open lang siya. The other one ay may naka-overlay na mineral oil that to provide an aerobic environment para still ang kanyang environment, walang oxygen for that. Okay, then try to inoculate your organism on that and try to observe for the color change after an overnight incubation. Okay, if both the tube here nag-change ng color, naging yellow, so we consider that one as, okay, fermenter. They try to ferment your glucose. Okay, both in the presence or even in the absence of the oxygen. Okay, so that will have yellow na colony tube that will identify your Enterobacteriaceae or even the Vibrios. Oxidizer, on the other hand, so this will have your na color change only in the open, but ang close natin, walang oxygen kasi, so it will have your no color change. The yellow na color lang niya is nasa open tube. This will still remain green. And thus, we consider that one as they try to oxidize your glucose. And that's in your Pseudomonas. The other one, your inert, you call this one non-oxidizer. So both the tube here left open and the overlaid with a mineral oil would have here no color change. Both of that remains as green na color. So this Campylobacter and we have your Enterobacter alkaligenes fecalis. Okay, the next one, we have here your TSIA or your triple sugar iron agar. So this is a triple sugar made up of, this is a special slant primarily made up of your butt, okay, and then your slant area. The butt area would have here the glucose, and for the slant area would have here your lactose and the sucrose. For the concentration of that, your lactose sucrose at 1%, while your glucose at only 0.1%. This being incorporated with your phenol red as your indicator, and H2S could be identified here by your ferrous sulfate plus your sodium thiosulfate would allow you to check if your organism here would have H2S production by the blackening of the colony. Another one, you could also identify if that organism here would try to produce gas by a crack formation in your culture media. Pag may crack, okay, pag may space, ganon sa ating culture media. Okay, so for our interpretation, so again, the original color of this one is red na color. But if your bacteria try to ferment your carbohydrate, it become yellow or they become acid. So fermenter is yellow, non-fermenter, we have here your red. So depending on kung saan nagko-color change. So pag dito sa taas nagiging yellow, that's your acid. Mean to say, try to ferment your lactose and sucrose. Kung dito naman naging yellow sa baba, mean to say, try to ferment your glucose. Like an example, K over A, so this one is A sa baba. So glucose fermenter lang siya. And 1A and A sa taas na. So that one will have here lactose and sucrose fermenter sa taas. And A din ito sa baba. I define that one is also a glucose fermenter plus my H2S. So that organism here try to produce H2S with the blackening of the colony because of that. Ang KIA natin, your Krigler iron agar, is made up only of 2 na sugar. So dito sa taas is only your lactose, wala siyang sucrose. Sa baba niya naman is only your glucose lang din. So ganun pa din ang color change. Not only that, it just differ with this one kasi this made up only of 2 na sugar. Lactose sa taas, tapos glucose sa butt area natin. Wala siyang sucrose. Okay, another test here, we have your ONPG or your orthonitrophenyl galactopyrinoside. Galactopyrinoside. Okay, that test will identify the enzyme beta-galactosidase. So this will help us to identify the presence of your lactose fermenter. Basically, the lactose fermenter require two enzymes, diba? Beta-permase, and we have your beta-galactosidase. But if your organism only possess your beta-galactosidase, wala siyang permase, it become a slow lactose fermenter, or you call this one your delayed lactose fermenter. Positive result for that is your yellow. Okay, and negative result would have your colorless. Okay, for the delayed lactose fermenter, just in the case of your Shigella sonnei, because by nature, ang Shigella natin hindi siya lactose fermenter, just like your Salmonella, di ba? Exception for that, we have your Shigella sonnei that would be considered to be delayed lactose fermenter for that. Okay, then we have also here your glucose metabolic end products. Okay, again, some bacteria try to utilize the carbohydrate, the glucose, and converting that one to your pyruvate by the different metabolic pathways. Some bacteria, however, further convert your pyruvic acid to your mixed acid, like your lactic acid, acetic acid, succinic acid, formic acid. And those bacteria try to produce here your mixed acid fermentation. Okay, so this is the basis here for our methyl red na test. Our indicator for that is your methyl red. Positive result is red. This will identify your E. coli. Negative result will be your yellow na color. And that's in the case of your Klebsiella and your Enterobacter. Okay, another option here for your bacteria, instead of converting your pyruvic acid to your mixed acid, you try to convert that one to your alcohol in the form of your acetoin, and further converting that one to your butane-diol. Our indicator for that, we have your alpha NAP tool, and then you add 40% KOH. It will give a positive result of red, negative is colorless. Since kanina, ang Klebsiella Enterobacter natin ay negative, so itong ginagamit niya. That will identify that one to have your positive result with your Vox-Proskauer test, while your E. coli, nag-positive na doon kanina sa metal red, and therefore expect to have a negative result here with your Vox-Proskauer. And then we have also here the amino acid utilization. So some bacteria, Enterobacteriaceae, instead of utilizing the carbohydrates as their carbon source, ang ginagamit nila ay mga amino acid natin. So when you try to hydrolyze your amino acid, remember your amino acids made up the amino group and carboxyl group. So some bacteria try to utilize the amino acid by hydrolyzing the amino group. Ay, wait lang, mali pala. Okay, by catalyzing the amino group here, hydrolyzing the carboxyl group by the enzyme, the carboxylase, we try to convert that one to diamine plus the carbon dioxide. So, some bacteria, Enterobacteriaceae, try to utilize the amino acid lysine. So, enzyme na ginagamit nila is lysine the carboxylase, converting that one to your diamine in the form of your cadaverine plus, of course, the carbon dioxide. Ornithine naman, so pag ginagamit ng ornithine, decarboxylating your ornithine, that would convert that one to your putrescine plus your carbon dioxide. Arginine naman, so they utilize the enzyme arginine dihydrolase, converting that one to your citrulline and further to your ornithine. Okay, ginagamit ng culture media for that will have your Mueller's decarboxylase. This one made up of 1%. We have here the glucose. We have here the amino acid. Kung ito siya, so kung tatlong gusto mo i-test, so should have 3 then. 3 na tube, each of that contains each of your amino acid. Arginine, another tube ornithine, another one tube is your arginine, lysine, and ganon. And that one is being at a concentration of 1% each of your amino acid. Indicator used for that, we have here your Bromcresol purple or plus your Cresol red. The positive result here would be your purple na color. Okay, in order for you to have the reaction in your the carboxylase na test, the first one requirement, you should have your acidic na pH. That will help us then to eventually change the color of the medium or the pH of the medium. The next one we have here the anaerobic environment or the absence of the oxygen. First, ang nangyari dito as again your Mueller decarboxylase na culture media contains here the glucose. So kung ito sa bacteria, unahin gagamitin na bacteria ang glucose natin. Okay, try to convert the glucose here to the pyruvate. With that, original color kasi ng medium natin is purple na color. Once the glucose sa culture media natin has been utilized by your bacteria, it will convert to your pyruvic acid. Magiging acid ito. That will change the color here at magiging yellow. Then eventually, if your bacteria contains those enzymes, lysine carboxylase, ornithine carboxylase, or arginine dihydrolase, that will eventually try to catabolize your amino acid to its corresponding na diamine group plus carbon dioxide, and therefore it will change the color here from the yellow to your purple. So kung positive siya, original color natin purple, maging yellow because of the glucose utilization. Panagamit ng glucose, so gagamitin nyo na ang amino acid that will again eventually change the color here from yellow, magiging purple siya ulit. Okay, we have here again the test for your decarboxylase test. So we have your lysine carboxylase, ornithine, and arginine dihydrolase, and we have here several of your Enterobacteriaceae. In the case of your lysine carboxylase, ang nagpa-positive lang natin would be all your Klebsiella. This includes your Klebsiella pneumoniae, Oxytoca, Enterobacter aerogenes. Okay, all the rest here are negative for that. But in the case of your ornithine decarboxylase, nagpa-positive lang natin would be your two na Enterobacter aerogenes, Enterobacter cloacae, and even your Proteus mirabilis. For arginine dihydrolase, ang positive lang natin will be your Enterobacter cloacae. Okay, another test, we have here the aminase na test. So, sa bacteria, instead of the carboxylating, di ba kanina carboxyl group ang inaatake niya, Ito naman ay they tend to utilize your amino acid as their carbon source by deaminating. So the amino group naman, deaminase or the amino group. Okay, so basically ito ang test natin na phenylalanine deaminase. So ang amino acid mo dito na ginagamit niya would be your phenylalanine. So kailangan mo ng bacteria ng phenylalanine deaminase na enzyme that will convert your phenylalanine to your phenylpyruvic acid. Then you add here the indicator in the form of your ferric chloride. It will give a green na color na reaction. This phenylalanine deaminase identifies the unique characteristic ng ating protease group that will give a positive result for the Proteus, Morganella, and your Providentia. Miscellaneous tests, some bacteria try to utilize citrate, acetate, malonate as their carbon source. Example for that, your citrate utilization with the use of your Simon citrate. So, ang indicator natin for that will be your BTB or your bromothymol blue. Positive result would be blue na color and negative result would be your green na color. This is part of your IMVIC reaction, indole, metal red, Vox Boscauer, and then your citrate. So, ito yung citrate na. Positive is the blue na color. Okay, the next test, we have here your Dnase. So, this will identify the enzyme Dnase. So, ang ating substrate would be the DNA and try to hydrolyze that one, converting to your short oligonucleotide if your bacteria contains the enzyme Dnase. Then, you just need to add 0.1N hydrochloric acid. It will have your clearing of the medium will give a positive results. Okay, so pag ang medium natin naging clear siya, so that's your positive result, that will identify your Serratia marcescens because meron siyang Dnase lipase, mga ganun, diba? Dnase lipase. Okay, and also your Staph aureus will also have your positive result for the Dnase. Gelatin liquefaction will identify the enzyme gelatinase. So it will just test the ability of the organism to liquefy the gelatin. So gelatin here will be converted to it become liquefied. Gelatin is medyo solid siya. But if your bacteria contains the enzyme gelatinase, that will eventually liquefy. Distinguishing here the true liquefaction with your false liquefaction. So pag may enzyme talaga siya na gelatinase, pag nag-liquefy na ang gelatin natin, even if you try to ref that one, hindi na siya magsusolidify. Pero pag ni-ref mo siya, tapos nag-solidify ulit, mean to say wala siyang gelatinase na enzyme. It's just a false na liquefaction. Then we have here the test for the indole, di ba? Start of your I sa IMVIC natin, this is your I indole. Okay, so this will identify the enzyme tryptophanase. Ang substrate natin is the amino acid na tryptophan. Converting that one to your indole plus your pyruvic acid plus your ammonia. Our indicator for that, we have here your Covax reagent, your para-dimethyl aminobenzaldehyde. Positive result natin is red na color. So again, your E. coli will give a positive result for that, whereas your Klebsiella, Enterobacter, Proteus vulgaris will give a negative result for your indole, but your Mirabilis will give a positive result. Okay, the next one, we have here the test for your enzyme urease. Okay, again, the urease enzyme is try to hydrolyze here the substrate urea, converting that one to your carbon dioxide and your ammonia. Indicator for use for that, we have your phenol red. So, positive result natin will also be red. Okay, so positive result, again will identify your Proteus, Morganella, and Providentia. Okay, culture media natin, a source of the urea would be your Christensen's urea agar or even your Stewart's agar. Okay, so we classify organism here based on their urease activity as rapid urease producer. Kung lahat throughout your medium red ang kanyang color, then we consider that one as a rapid urease producer. Pero pag medyo pink lang siya, or let's say, okay ganyan, red sa slant pero hindi throughout the medium, and some other part, hindi siya ganun ka-red, then we consider that one as your slow urease producer. Yellow is the negative result for this. Next one, we have here the lysine iron agar. So this will identify our bacteria if they can either carboxylate or deaminate specifically the lysine na amino acid. So, dalawang enzyme ito, the aminase for the amino group, kung ito ang ina-attack nila, or carboxyl group here, if they try to attack the carboxyl group, then they have the enzyme, the carboxylase. Okay, the content of our culture media, we have here the glucose, then we have here your lysine at 1% pa din ata. Indicator for that, we have here your bromcase or purple. And for the H2S, this one would have here your ferric ammonium citrate with your blackening of the colony. So basically, again, the slant area will identify the enzyme, the aminase, lysine the aminase. Positive result for that, we have burgundy or plum or red na color. Dito sa sabat area natin, it will help us identify the presence of your lysine decarboxylase. Okay, this will give a purple na color. Again, just like kanina sa ating decarboxylate din, di ba? So, yellow is a negative result. Una-una, i-attack ito ng organism natin glucose. Converting that one to acid, magiging yellow siya. Original color niya is purple. Okay, purple, tapos yellow. And then, if your bacteria contains here basically this enzyme, it will change the color from the yellow. So, pwede siya magiging plum or burgundy here if that one would have the enzyme na lysine decarboxylase. Magiging purple siya sa pot area if that one would have the enzyme na lysine decarboxylase. For example, itong result natin, purple sa taas, yellow sa baba. Purple here is the expected na, wait lang. Okay, example, red sa taas. Okay, so red is a positive result. So, meaning to say, meron siyang lysine, decarboxylase, deaminase. Sa baba, yellow, that's negative result. So, wala siyang lysine, decarboxylase. Then, meron siyang blackening of the colony, identified by your ferric ammonium citrate. Okay, so that will be interpreted here as H2S producer. Okay, your lysine iron agar will help us differentiate between Salmonella and Citrobacter because they almost have the same characteristics. Again, your lysine iron agar will give a positive result with your Salmonella but not with your Citrobacter. Another biochemical test, we have here your three. Motility, indole, ornithine. So there are three tubes. Motility is identified here by spreading of the colony away from the area where you try to inoculate. Parang lumipat siya. Like kung dito ka nag-inoculate, okay, so parang eventually, parang andito na ang growth mo sa kabila. Lumipat siya, then that would identify your motility na test. Indole test will give a positive red na color. Then we have your ornithine, we have your purple na color. Another one, you could also have sulfide indole motility, sulfide for the H2S. So expect to have here blackening of the colony. Indole is again red, motility spreading the colony away from your inoculated site or area. Another one, we have your MAG test. Okay, your 4-methyl umbelliferyl beta-glucuronide for identification of the enzyme beta-glucuronidase. So this is a fluorometric method at 366 nanometer wavelength UV light. Positive result will have blue na fluorescence. It will give a positive result for your E. coli except your enterohemorrhagic. Diba? We consider that one as your sorbitol SMAC negative and MAG negative. So, but all the rest na species ng ating Escherichia coli, they will give a positive result for that. And negative also, walang fluorescence, is also identified with your Pseudomonas. Okay, so thank you.